Hey guys, Mr. Adamson here again. Welcome to another little lesson on another form of energy. This time we're going to talk about kinetic energy. So we've talked about previous different forms of energy. We've talked about gravitational potential energy, which is stored energy. Now we're going to talk about what do we do with that stored energy. So I used the example before with potential energy. Well, you got a little dude standing here and he's just waiting to run a race. Here's the starting line. So he's all that energy is stored up within his bodies and his muscles. Well, then the starter blows the whistle and boom, he's gone. And that's when that potential energy starts going into kinetic energy. So kinetic energy, if we look at the definition here, the kinetic energy of an object is the energy which it possesses due to its motion. So it's moving. And it is defined as the work needed to accelerate a body of a given mass from rest to its stated velocity. So here's some key words when trying to figure out the formula. The body of a given mass from its rest to its stated velocity. And therefore our formula for kinetic energy is EK equals 1/2 mv squared. M being mass and v being velocity. So if we were to work with this formula here, we could say that we had maybe a 0.3 kg ball and it's being pushed horizontally, so being pushed along the ground horizontally at a speed, so our v, of 20 meters per second. Calculate the kinetic energy of the ball. So therefore we type it in our formula, 1/2, our mass being 0.3, our speed being 20. Put that through your calculator and you're going to get 60 joules. Now you're probably looking to, well, what was the actual significant digits of this answer? Well, let's go, we have 1 here and we have 1 here. Therefore we look at our answer and we have 1 there. Therefore that answer is correct. So there's a way to use kinetic energy. Now kinetic energy is a little more difficult to manipulate the formula, and we'd manipulate the formula of potential energy. And I'm just going to go to another slide here and show you the different ways to manipulate kinetic energy formula. So if you're manipulating the kinetic energy formula, which we start with EK equals 1/2 mv squared. Well, let's say that we have to find mass. So the first thing that we got to do is we got rid of this half. So this half has 1/2. So the easiest thing to do would be to multiply by 2, which is the exact opposite of saying like 2/1. Therefore we can cancel that, but whatever you do to one side you have to do to the other. So we multiply this side by 2. Now we have 2ek equals mv squared. Now how do you get rid of that v squared? Well, let's divide by v squared. Whatever I do to one side I do to the other. Divide by v squared, so cancel, and we get 2ek over v squared equals m. So there's the first way to manipulate the formula to find mass. Now the next thing we need to do using our original formula, so ek equals 1/2 mv squared. How do we get velocity? Well, just like before, we got to get rid of the half. So multiply by 2/1, cancel, multiply this side by 2. So we have 2ek equals mv squared. Got to get rid of the mass, divide by m, cancel. So now we have 2ek over m equals v squared. Now most people usually stop at this position, but this isn't quite right because we still have v squared right here. Well, how do you get rid of a square? You square root something. So square root that side, I have to square root this side. And therefore I get the square root of 2ek over m equals v. And there's the two ways to manipulate your formula if you have to find mass using the kinetic energy formula, or if you just have to find speed using the kinetic energy formula. So hopefully that's useful for you when you're putting in your calculations, and this can be something we can further discuss in class. Thanks for listening.
Made with Doodlecast Pro.